So hello guys, in this video we are talking about real questions on Spark configurations, like how we can uh, set the configuration for cluster, number of executors, cores, executor memory, like that. So let's discuss about this. So first question is, what is the difference between executor memory and driver memory? Driver memory is a RAM for the driver JVM, the program that run your code, create Spark context, plan queries, schedule tasks, and collect result. It is a coordinator. Executor memory. Executor memory is a RAM for execute JVM, the workers that actually run your transformation task and create sketchy data. They do the heavy processing. Driver memory is typically small, 1 to 4 GB, unless you are collecting the collect function on large data frame or broadcasting many large tables. Executive memory is where most tuning happens. It must be large enough for data processing, shuffle, and caching. Thumb rule is increase driver memory only when you see driver out of memory error. Increase executor memory when you see executor out of memory or executive split disk or disk split. Second question: what do you set executor core to 5 and why not 10 or 1? 5 is an industry sweet spot for three reasons. First, HDFS throughput. The HDFS client has throughput degradation beyond 5 concurrent read threads per executors. More than 5 core, meaning spreading reading data slower, not faster. Second, memory per task. With 5 core sharing, with 5 cores sharing executor memory, each task get responsible slice. With 15 cores sharing the same memory, each task get little RAM. That split to disk become frequent. Third, JVM overhead. With 1 core per executor, you need more executors, of course, then 1 per core, each with its own JVM setup cost, garbage collection overhead, and yarn container overhead. 5 core balance the parallelism with JVM efficiently. If the executor memory is a large, very large, like 14 GB means 40 GB, you may increase to 7 core. If memory is small, like 2 GB, reduce to 2 or 3 cores, but 5 is always starting point. Question number 3: what is in memory overhead and why do you need it? Answer: when yarn or Kubernetes allocate container for an executor, the container must hold executor JVM memory plus of heap memory for thinking outside the JVM heap. JVM internal buffers, network buffer, Python sub-process memory for PySpark, and overhead OS means कंटेनरमध्ये JVM मेमरी असते, प्लस ऑफ हीप मेमरी असते, प्लस पायथॉन प्रोसेसवाल्यासाठी पायथॉनची वेगळीच मेमरी असते, आणि OS ओव्हरहेड त्यासाठी सुद्धा मेमरी लागते. त्यामुळे दिस इज एक्स्ट्रा मेमरी is overhead memory. The formula is maximum executor memory into 10%, or default is 385 MB. For an 8 GB executor, yarn allocate 8 GB plus 819 means 819 MB, means near about 8.8 GB total. This matter because if you set executor memory is equal to 8 GB on the node where yarn container limit is 8 GB, the actual allocation is 8.8 GB, exceed the limit. मीन्स यांची कॅपॅसिटी आहे 8 GB, पण आपण अलॉकेट केली आहे 8.8 GB, मीन्स 8 GB एक्झिक्युटिव्ह मेमरी प्लस 800 MB फॉर ऑफ हीप मेमरी. बाय डिफॉल्ट इट इज असाइन. Then exceed the yarn and yarn kills the container with called you will get the error container killed by yarn for exceeding memory limits. The fix is either reduce the executive memory to leave room for overhead or increase the yarn container memory limits. In Python specifically, the Python subprocess the run your code separated from JVM lives in overhead. If you have heavy UDF or large Python objects, you need to increase overhead, often to 1 to 2 GB. If data is 10 GB, how do you decide the configuration? I follow the systematic calculation. 10 GB processes Parquet expand to 30 to 35 GB in memory, means 3-4x partition compression ratio. Spark need RAM for input data, shuffle intermittently, means can be same size as input, and output if caching. Again, 10 GB compressed Parquet expand about 30 to 35 GB in memory. Spark need RAM for input data, shuffle intermediates, and output if caching. The total working set is 60 to 100 GB. I always set executor core to 5. Then I calculate executor per node. How we can node core -1 for OS divided by 5. So total is, so for 16 core node is equal to 50, means 60 core -1 for OS, then is 15. 15 divided by 5 is equal to 3 executor per node. Executor memory per executor. Node RAM -2 GB for OS divided by 3 executors. For node, our node is 64 GB. So 64 minus 2 for OS, then 64 minus 2 divided by 3, because 3 executors are there. It is near about 20 GB. So set to 18 GB leaving buffer for overhead. So executor memory is 18 GB. Number of executors, like how we can calculate executor per node into nodes. -1 for application master. For example, for 5 nodes, 3 into 5 minus 1 means 3 into 5, 15 minus 1 is equal to 14. Number of executor 14. Driver memory 2 GB is sufficient, since results are returned to storage, not collected. So shuffle partition in memory data is 35 GB divided by 180 MB target. So total are 273 partition. So around 300 partition we can give. Enable AQE to handle any remaining SKU partition. So basically executor core 5, then executor memory is 18 GB, number of executor 14, shuffle partition 300, and driver memory 2 GB. Next question: what is the difference between spark.sql.shuffle.partition and repartition? Shuffle.partition is a Spark configuration, SQL configuration that controls the number of partition produced after the shuffle operation. When you do group by join order by, the default is 200 partition, correct? So this applies to all shuffle operations in the session unless the old return. Repartition of n is a transformation that explicitly changes the number of partition by performing full shuffle. Useful when you need to increase partition count or distribute data evenly by specific column. Repartition in bracket n comma column name. Shuffle data so that all rows with the same column value go to the same partition. College. It reduces the number of partition count without full shuffle. Much cheaper when shinker partition before writing. In practice, set spark.sql.shuffle.partition based on the data size, means for example around, if data is 35 GB, so divided by 128, we will get 273 partitions. So around 300 partition we can assign. Use repartition when you need to redistribute data for better performance and or join before join. Again, use repartition when needs to redistribute data for better performance or before join. Use coalesce when reducing output file count before writing. Question number 6: what is dynamic allocation and when would you use it? Dynamic allocation is Spark automatically scale the number of executors based on the worker load. Again, dynamic allocation is Spark automatically scale the number of executors based on worker node. adding executor when tasks are queried, and removing idle executor when they have been unused for configurable timeout. Setting like spark.config.set in bracket spark.sql. Spark dot sorry again spark.config.set in bracket spark.dynamic allocation dot enable comma true spark.dynamic allocation dot minimum executor comma 2 first enable true, minimum executor 2, max executor 20, initial executor 5, and spark.dynamic allocation dot executor ideal timeout is 16 seconds. 60 yes. I use dynamic allocation in shared cluster environment where multiple jobs complete for resources. A long running streaming job should not hold 20 executor while waiting for new data. Why? With dynamic allocation, ideal executor release for other job. Use static allocation when I need predicted performance and resource isolation. For example, high priority production ETL job that must complete within a SLA. With static allocation, I know exactly how much compute is dedicated to my job. In Databricks, dynamic allocation always enable and managed automatically by cluster autoscaler. You just set min and max workers. Next question 7. What is Spark Unified Memory Model? Before Spark 1.6, executed memory for shuffle and aggregation and storage memory for caching were fixed fraction for heap. If one run out of, the other could not lead its unused space. म्हणजे एक 1.6च्या अगोदर दोन मेमरी होत्या, एक्झिक्युटिव्ह मेमरी आणि स्टोरेज मेमरी. बट ते एक मतलब समजा एक्झिक्युटिव्ह मेमरी फुल झाली आणि स्टोरेज मेमरी रिकामी असली तरी एक्झिक्युटिव्ह मेमरीसाठी ती स्टोरेज मेमरी वापरू शकत नाही, त्यामुळं अनयुज्ड मेमरी यूज होत नाही, आयडियल राहते ते. सो फॉर दॅट युनिफाईड मेमरी मॉडेल कंबाईन देम इंटू वन पूल, म्हणजे ते कंबाईन केलं एक्झिक्युटिव्ह मेमरी आणि स्टोरेज मेमरी, आणि त्याला म्हणतो आपण युनिफाईड मेमरी. So executor and storage share the single pool and can borrow from each other. If execution need more memory, the storage has ideal executive memory borrow it and may evade cache data. If storage needs to cache data and execution is ideal space, storage borrow from execution. The total executive memory is equal to executed memory means minus 300 MB reserve into spark.memory.fraction. Default is 0.6. User memory for 0.6. User memory for your custom data structures get the remaining 40%. म्हणजे काय 8 GB एक्झिक्युटिव्ह मेमरी असली तर -300 म्हणजे इंटू 6 म्हणल्यावर 10 GB असली तर त्यातले 9700 होणार इंटू 0.6 मिलवर अराउंड 7 GB ही यूनिफाइड मेमरी को जाती है, और उसमें से 3 GB पर ईच, एक्सिक्यूटिव मेमरी 3 GB, स्टोरेज मेमरी 3 GB. Okay, this model is important to understand because it means catching that large data frame can evict shuffle data, causing recomposition. If you see unexpected caching evocation or shuffles reprinting, it often means the unified memory pool is under pressure and you need more executed memory. Question number 8. Job keep failing with garbage collection overhead limit exceeded. So what do you do? Garbage collection overhead limit exceed means JVM is spreading more than 98% of its time on garbage collection and recovering less than 2% of heap. The JVM is almost out of memory and spending all time to cleaning up. Root cause: too much data per executor, too many objects accumulated in executor heap, or memory fragmentation. My debugging approach: first step, check Spark UI executor tab. Look at garbage collection time percentage per executor. If above 10%, garbage collection is a problem. Step 2. Increase executor memory. More heap means less frequent garbage collection. Reduce data Third step, reduce data per task by increasing partition count. Spark.sql.shuffle.partition is equal to 400. More small task. Fourth step, check the larger broadcast variable or accumulators accounting accumulating in memory. Fifth stage, if using UDF heavily, check if they create many short-lived objects. UDF are hard for JVM garbage collection to optimize. Step 6, enable off-heap memory for tungsten operation, like spark.sql.set, spark.config.set, in brackets spark.memory.offheap.enable, true, spark.memory.offheap.size in comma 2G. Off-heap memory is not garbage collected, so it reduces the garbage collection pressure significantly for large shuffle operations. That's about Spark configuration. We will see. So bye.